Good evening. This is the last video for the revision session we have for the advanced manufacturing. I know that tomorrow is going to be the final date, but sorry, because I had to mark your papers for the assignment number 6 before I go to do through this sliding sheet. So first, before I go to go through the PLC revision, because actually I'm going to have a question for the PLC, I would like to tell you something about the calculation we had for the assignment number 6. In the question number 1, when we talked about the time required for the manufacturing, using the maximum and the minimum values for the velocity of the cutting tool, we should look for the TU value. So the TU value equation should be used to find the time required to manufacture one piece. There's no the TC time we calculate at the first part of the calculation. That's number 1. The other common error was to find the value of the cost of the tool. So just remember, once again, we have to look carefully at the equation for the cutting tool cost. We have to find first the number of the edges we are going to use for the cutting tool. Just remember, is going to be the number of the edges the number of the times we can grind the cutting tool plus the original edge we have. So if we are going to have one edge, we buy the cutting tool with one sharp edge and we can grind it for 6 times. That means the useful edges is going to be 7. So we have to divide the cost of the cutting tool, the price of the cutting tool, by the number of the edges. For the grinding, we have to multiply the time required for grinding of one edge by, you have to open the bracket, you are going to add the labor cost plus the overhead cost for the grinding. This will be in dollar per hour for both. So you have to divide this one by 60 to have it per minute. Okay, that's how to find the value of the CT. So now go back to the PLC example. This example is not going to be 100% similar to the one you have in the final exam, but it's going to help you to identify the problem you are going to have in the final exam. So we are going to consider that we have 2 sources of lights. And we have a photo sensor which is going to tell us if the intensity we are going to have by turning both lights is going to be enough to generate a signal which is going to give us a buzz sound. So on the other side we have the on-off buttons, and this one can pass the value of the intensity, light intensity, and turn off the buzz or turn off the buzz. So we are going to consider that the value of the input from the source number 1 is going to be x1, from source number 2 is going to be x2, and the output we are going to have by having these 2 values is going to be the photosensor output y1. The y1 will be fed as an input to the microphone, and this will cause the y2 output. Now we have to show this one on the PLC box as inputs and outputs. So first we have to make a table, put the inputs on one side and what the outputs we are going to have on the other side. Now the inputs are going to be the x1, the x2 on and off switch. The output in this case is going to be the y1 signal. We are going to activate the photosensor to give the digital signal of 1. This digital signal will be feedback as an input, and this will generate the output signal of y2, which is the buzz from the microphone. Now in the box, this is the box of the PLC. On the side we are going to have the input number 1 is going to be on off, because this one can bypass the x1 and x2 value. The other signal should be x1 and x2. Now because we checking the intensity, if I'm going to have a certain light intensity, it will turn on the buzz. It's not going to be just a photosensor. When there will be a light, whatever the value of the light intensity is going to turn the buzz, and this will generate the output of y1. The y1 will be feedback once again through the PLC. It's going to be an input on the other side to generate the output of the y2. Okay, now this is how to identify the inputs and the outputs, and on the other side how to put the things as an input and outputs on the PLC ports. Because you remember we said in the PLC you have the input ports and we have the output ports. So this is how we again identify the thing. Now to make the ladder diagram, this is the ladder, and now we have to make the cells. So the first one is going to be x1 and x2. This is the AND function. So we should have x1 and x2. On the other side, we can simply press the on button to start the device. So it's going to be OR. So it's either x1 and x2 signal or the on signal. And this will generate the Y1 output to the through the photosensor. Now, if I would like to turn off this one, simply again to have the off button, which is always going to be normally closed, and we're going to press it to make it off. The Y1 is going to be fed back as an input, and this one will generate the value of the Y2 output. Simple as that. So what we have here is AND for X and X2, X1 and X2, or for the on. The whole thing is going to be AND NOR. That means that the off should always be closed. Otherwise, we're going to press the button and we're going to open the thing and then turn off. And then we're going to feed the Y1 to turn the Y2. So as simple as that. The example you are going to have, as I told you, is going to be something similar to the one you had in the classroom. I mentioned 3 examples. I cannot identify which one is the one you are going to have in the final exam. Well, I know that's quite mean, but it's your duty to be, well, look around you in the class, remember everything we said. Anyway, well, I wish you good luck. And if you need any help, you can still ask me. I know that the exam is going to be by 9 a.m. Maybe at that time I'm not going to be at school to help you. But in all the cases, I will try to cooperate to answer all the emails you are going to send me through the night. Okay, now before we are going to turn off this video, because this is the last slide, I would like to talk something about the utilization of the robot. Okay, now I advise you to use the same method I show you in the previous video, the part of the G code and the robot utilization, because this will help you to find what will be the cycle time for one part. That's when I'm talking about the part number 2. Okay, utilization time of one part, and it's going to show you how to calculate the utilization time. For the robotic arm. Simply, we are going to add the waiting time on each machine for the second part, subtract it for the waiting cycle time, and this will give us utilization time for the robotic arm. By divide this time on the cycle time, we are going to have the utilization percentage. For the equations, too many students ask me about the equation we are going to have supply. Now, PLC doesn't have equation. The G code, you are going to have all the codes. Just remember, always you have to keep the offset from the cutting edges. You always have to be on the tool path, which is offsetted from the edges of the cut. You are going to have the equations for the cutting tool calculations, the example we talked about at the beginning. You are going to have the equations for the UCL and UTL and the other equation we had in the control of the quality control of the manufacturing. For the question number 2, question number 3, in the assignment number 2, you have to memorize all the equation for the PC and the PCI. Well, actually, this shouldn't be a hard thing. Try to send you a hint about what you have to do with the numerical control equation. Numerical control equations, because you are going to have the open loop and the closed loop. You have to study something about the FMS. You have to study something about the family, the parts families. You have to read something about the surface roughness. You have to read something about the CMM, that's in the lab lecture. It was lecture number 2. I sent it to you by email. Just try to find something about the CMM, the surface roughness, the sine bar, the laser hammer, and Taguchi. What's the meaning of Taguchi? And what is the Six Sigma? What are the other definitions? We have 2 main definitions through this one. I cannot cover it for this one, but I actually highlighted that for you in the lecture notes. I know you will tell me, okay, now do we have to go through all the lecture notes by this short time? Well, actually, you should do this one earlier. The other thing I would like to talk about was, going back to the equation. In the robotic lecture, we had an example which contained a quite rich information and equations. You have to memorize this equation. It's not going to be supplied to you. Okay, now you are going to have the question, but you have to memorize all the steps to do the answering. What else? You have to be fully understand what do you mean by the G coding, because you are going to have a question about a simple case and you have to analyze the code and answer the questions. Okay, so I'm going to send a short video later telling you about the numerical control calculations. Okay, have a good night.